Hi, how are you?
Morning. Oh, why's my sound weird? Can you hear me okay?
Yeah.
A second. Uh, okay. Can you say something again?
How are you?
Okay.
Can you hear me?
So weird. That sounds being strange.
Oh.
Um. Yeah. It's a weird time for me. I don't know how to. I'm not sure how much more to elaborate, but it's just this is just the strangest of times for me. So.
Yeah.
I woke up this morning early because I wanted to go over manuscript stuff last night, and I didn't get to. So I'm like, all right, I'll wake up this morning, like 2 hours more than I usually do, and I woke up to a voicemail from someone very close to me, and they were telling me that they got hit by a car.
Oh my god.
They're okay, thankfully, but it was like, what?
Yeah.
So I did not have the most productive morning as I intended.
Oh.
And it's like, it's just wild and strange times. So I don't really know what to say about that, but I'm sorry I didn't get to do some of the stuff that I wanted to do this morning. But it's just like, wow.
Yeah. Wow. It sounds horrible. I mean, but yeah, it's, well, I think we're, like, in the deadlines that are coming up pretty soon. I think we're getting there. So, let's see. What do we want to talk about today? We have some of course, we have the deadlines coming up. I wanted to kind of go over those in the meeting and discuss a little bit about that. And then the project summary cards, I wanted to talk about that a little bit. And some other, we'll probably go back to the GitHub repository and all, like looking at how that's set up, and then thinking ahead maybe to some things later on this spring. What's on this agenda for that period? So, what's going on with you?
Like for what to do today, you mean?
Well, I mean, do you have something to talk about or review?
My computer's being really weird today, as well. So I might have to be a little bit slow in general. I don't have a lot of like new stuff to say. I did finally finish the Ethics and Society card. I might talk a little bit more about the New York Women Celebration of Women Computing stuff. I've done like some minimal promotion for that because I've been involved with them for a while. So I might talk a little more about that. I might go over my Ethics and Society stuff a bit more. But I mean, I wouldn't mind going over the manuscripts again. Like I know how to do that anyway, but I don't have like any. I've done a little bit of stuff, and I'm trying to. My computer's being uncooperative, but like my Slack application is completely glitched out right now. So, Daniela reached out to me over email. And that was really cool. And she's already involved in the lab, so hi, Daniela. Has she been in video yet?
I don't think so. I've talked to her on Slack quite a bit, so.
Yeah, she's great. I'm really happy that she's doing it. She reached out to me. She sent me a pleasantly formal email asking me to like collaborate on some of the issues in GitHub. And that's cool. So I guess I'll mention that. I can she mentioned she gave me an introduction, and she's done some cool stuff like everything post like at Simons Institute for Theory of Computing at UC Berkeley and University in Italy that she's been at. She's interested in our lab. I think she's already. I think it was very nice for her to send me the email, but I think we've already I kind of interacted with her indirectly here in the lab. So if you're watching, hello, thank you for your email participation. And definitely yes, you can. She mentioned some of our old. Actually, I'll mention that when we get to if we do the GitHub project board or stuff. I don't know what order you want to do things in, but she mentioned a couple projects there that she'd like to work on, and I'll update that and stuff like that when we talk about it.
Okay. Yeah, I've been interacting with her. She's been contributing to some of the papers, and we've been going over that. And she asked me about the project that. I'll get into the projects in a minute, I think. But she asked me about the MetaBrains project and how she could become involved. So that's good. I just had put that up on Twitter. I don't know if that was what triggered it or if she was just looking through the messages on the Slack and ran across it. But that was good. So the project cards, like we've said in previous meetings, are there to build awareness of what's going on in different projects. So it kind of summarizes everything and helps you kind of understand what if we throw around a name of a project, what that is. So why don't I share my screen? Let's see. All right. So you can see my screen here. Okay, and you're in that as well. So these are the project summary cards, and these are. I need to do these. We have a couple of, so first of all, I've been putting them out on Twitter regularly over the past week. So I have a bunch of cards that are already up, and that's under this finished category. And so we have building up epistemological directories, MetaBrains, reconstructing cybernetics, developmental Bradenberg vehicles. Those are all out. I'm putting them out like every other day. So, and then to go, we have the Technology and Society card, Cognition Futures, Innovation and Open Science, Allostasis Machines, Education and Content Streaming, Modeling Neural Organoids, which we'll talk about in a little bit, and Developmental AI. So some of these aren't really completed yet, but, that's okay. I don't know how many more we should put out in that schedule because, after about 5 or 6, it becomes overwhelming for people. Like, they're seeing them every other day, and it's like, should we take a break for a little bit and then come back to them a little bit later? Or?
Oh yeah, I think they could be like periodically posted. Also, like as a side note, I want to talk to you about Facebook because I know there's a lab page there. It might be cool to just post these on there too. Just sort of like advertisements or like call for involvement or whatever. And I think the page could be updated a little bit. But yeah, I think like periodically doing that and making sure we have them all like on the website or something, just a list of like here your project card or GitHub or on Medium where like was the master list of them. I think just stuff like that, just simple, like basic administration, marketing, whatever stuff. Like nothing fancy though.
Yeah.
But yeah. Oh man. Another week goes by and it's like all the stuff that I didn't quite get wanted to do, and so I'm sorry. I feel like I really haven't been doing exactly what I wanted to do the last week or two specifically. But it will get there. There's just like a little bit more of this would be where I wanted to be. So.
Yeah. So then I wanted to show the Medium. Let's see, I'll share my screen again. Okay. And then this is, of course, the way they look on the Medium. So we have like a category. I think it's called for involvement. And that's where we have each of these cards. So this is an example for MetaBrains. And just using this heading, which is basically the same thing on every project except for the title. Gives basic information, the card here, which I just showed, and then the links down here, which are sort of not in this image, not embedded in the image, but you can actually link them. So that's what we have, and then I think that's. Oh well, I don't know why. There are two more than that. Okay, so there's some down here. So I guess it.
Yeah, I was playing around with the homepage layout a little bit, and I think it'd be good if we had a specific call for proposals. There's events, and there's Saturday morning NeuroSim, a specific heading for the call for proposals might be good. And I'll look into that later.
All right. Yeah, I mean it's the organization of it is. I don't know if people are hitting this, if they're hitting the front page of the Medium, or if they're seeing this on social media and they're clicking into the project. But yeah, I don't really understand the way that things get organized here. I know we have the keywords, but other than that, I'm not sure how. I guess there's a bit of a template.
It's not the most clear, but I can also show you the settings where people want to adjust them. But there's a little bit a little funny, but it's all right.
Yeah. So that's pretty much that. I mean, so we'll just keep going, and we might take a short break of maybe a week or so to flush out the system, and then start with other cards, or we can put out cards on a regular, we can re-announce it on Twitter after a while. We have all of we'll have all of those up eventually. So
yeah.
I did want to come back to this, the modeling neural organoids, and notice that's a new one that I put up. So yesterday I actually had a 2-hour meeting with, I don't know if you've seen him in Slack, Morgan Howe.
Yeah, he's on Facebook too.
Yeah, I've seen him he's followed me on Twitter for a while, and he's pretty active there, and he's actually in the San Francisco Bay Area, and he's interested in neuroscience. I think he does a lot of EEG, which is neuroimaging, and he also is interested in organoids. And we talked about organoids a while back, and he found someone from University of California, Santa Cruz, Katerina, and we're gonna try to work in a group on neural organoids. We just met yesterday to kind of figure out where we kind of sit collectively, but we'll see what happens. It would probably be a lot of there'd be a lot of data science type stuff going on, finding data sets and analyzing them and saying things about organoids and their morphology and all this. Depending on the data set, you can get a lot of information. So if people aren't familiar with neural organoids, they're these structures that you grow from stem cells, and you put them in what they call a bioreactor, which is a 3D chamber, and you have this blob of cells. They're stem cells, so you give them the right conditions, the right media, and they differentiate. You can use factors, which are like transcription factors or mRNAs, and they get inside they infect the cell, and they basically change gene expression, and you end up with this with these cells that differentiate over time. But they also the population expands, and they grow in different shapes. So if we know anything about embryos, that embryos start as a little ball of cells, and then they expand in number of cells, and they start to differentiate into different types of cells. But they also change their shape, so you end up from going from a ball to something elongated to something that has maybe limbs or fins or a head and a tail. So you get this sort of differentiation. Now in neural organoids, it's less organized than that. You get these weird shapes that you can depending on how you culture the cells. So it's almost like I don't know. I don't know if anyone's ever seen where they grow like ears on the back of mice. This is something they do in like regenerative medicine. It's a common image of like the coolness of regenerative medicine. They grow ears on the back of mice, and it's just basically like trying to grow organs in a way that, so you can grow like, actual defined shapes of things. So there's an element of bioengineering. There's an element of developmental biology, although it's not true development. But you're basically, you get a bunch of cells, they differentiate, they take on different shapes, and then you can analyze that process. So, that's going to be more, I think, relevant to DevoWorm in some ways too. And so, I don't know how much we'll do. Well, we might talk about it a little bit in this group, and of course, people in this group are welcome to participate. It is, it depends on what, there is a lot of biological sort of, there's a barrier that requires some knowledge of biology. I mean, you can learn about it, but it's like, if we read some papers, it's going to be pretty unintelligible, perhaps. So there is that learning curve. And then, of course, if you're doing data analysis, that's something you can do if you know how to do that. That's just something that you do. It's already in your field of domain, your domain of knowledge, but you'd just be learning about this other thing. And that's typical, I think, in data science, where you always have to learn new domains. So I think it's really interesting work. I don't know where it's going necessarily yet, because we're just trying to establish something. So now the organoids, they're probably about, there are a growing number of labs that are doing it. I'd say it's more than a handful at this point. It's probably maybe over a dozen, because it does cost, like, there's a lab overhead in terms of equipment and reagents and things that you need to do this. But like, they also a number of these labs are releasing their data so that the data is open, and it's, there's a way that we can like get access to data to do some of this stuff. So that's what we're doing with that project.
Okay, I have some comments about that.
Okay.
One, I'm very interested in that, and I don't know if it's like obvious or not. Like, I'm in DevoWorm as a, I'm not, that's not my main thing I do, but I'm in there, and I was thinking about that regarding DevoWorm, and also, like, I wonder if I feel like I want to reach out to Akshara about this. I feel like she might be interested in this, particularly in terms of like the data stuff as well. So that's one thing. And I am very much curious to see where it goes, especially working with what was the name? Morgan?
Yeah.
I'm curious to work with them, and what you guys envision for using the data, and what you'd like to do, because I'm just saying I'm very interested in that. And on a related note, that's probably the best way possible, because everything in academia is strange right now, and I don't know I've applied to a bunch of things, and I'm applying to more. The one thing I'm like absolutely committed to doing, and I'll be starting like next week, is a program. Let's see, a program in data science, and it's you might have seen me on Twitter or elsewhere, but Miguel Nunez, he's someone I respect a lot, and he's done a lot of good things. He's been in like NeuroMatch and many conferences, and we were both at the MIT Brain Mind Machine summer course together and stuff like that. And he's just, I look up to him. as an academic person and someone who's really knowledgeable. And he really recommended this program. He finished it completely, and it's a MIT X MicroMasters in data science and statistics, and I feel like it's something I can just start doing because I want to get. I don't know what's happening this year in some areas of the world in my life. It's like, okay, I can do this, and it's really good because like its credits are it's valid in and of itself, and the training's really good. But also has credits that you can transfer into some other things specifically too at the graduate level. So like I'm like 100% committed to that, and so I'm looking for applications for. I'm going to be learning data science related stuff, and I'm looking for outlets for them. So like this, what you're talking about seems to fit really well with that. So there's a lot of personal alignment with that. And I've been looking for things like I know we have like some other stuff, but like having some real world data sets and bigger data sets and being able to apply it to stuff will be great. So that's like a big interesting thing for me. And the collaboration, like I'm curious of his ties with other people and so on. That's cool. And also like I'm not versed much into biology, but given the time of everything else, like I wouldn't mind working together. I'm sure people in DevoWorm would know more. But like I would suggest like creating a resource list or be like a very simple primer for biology that will be related to it because I want to learn it, and I'm sure people there, a lot of people in the lab, in DevoWorm group, so I'm sure they already have something going. But I would like to. I feel like okay, I want to do this. I'm going to be learning a lot of the data science stuff over the next. Rest of this year, basically, starting next week. And if I can get, I know I have a billion projects going on, but like, if I can get into the biological requirements, I feel like that would be a legitimate path for me and other people as well. So, I'll mention those things.
Yeah. Yeah, I think that, I think this is going to require some, and again, like this is a pretty new area, so it's not like there's a lot of, it's not like you're going to come in with a PhD in neuroorganoids. I mean, people are doing it, but the Katerina, we were talking about her interests, and she's actually interested in using reinforcement learning to sort of predict what the organoids are doing. So let me see if I can draw this out. I have my tablet again. I'm going to share my screen.
Before I forget, I would also mention my friend Logan Thrasher Collins, who I mentioned a few times here, and we've seen him on Twitter and stuff.
Right.
I'm not sure if he's interested in neural organoids specifically, but I kind of think he is. He's interested in like synthetic biology and new biology, so I have a potential connection with somebody who's potentially very interested in this and working in sort of like in a master's program in related industry stuff, who might be like a really useful contact or someone who would be really interested in this as well. So I want to mention him.
Yeah, we should. This is something that. Well, so I'm going to try to assemble a bibliography of papers and that, and then we'll get ramped up at some point. We'll get some data, and it'll become more defined. So let me go over this real quick. What's going on with see if this works this week. Okay, good. So you have, like I said, you go from you gotta get that one there. You go from like a ball of cells, which is like this clump of, undifferentiated stem cells, and then you add media. And you add like environment, which is like it could be like a bioreactor. It could be they usually don't use plates of cells, but they use media, controlled media, which has growth serum and other sorts of neurotrophic factors in it, and they use this bioreactor, which is like a 3D vat of this stuff, and the cells either can be plated on some sort of like scaffold, or it can be just kind of like in, growing freely. But they grow as this ball, and then they grow into shapes. So they might take on this elongated form, or it might be kind of almost like a coral. We don't really know what kind of shapes they take. I have to go get a collection of images of what they're coming up with, because there's a physics to it. We've talked about this in DevoWorm. Each of these cells now that grow in here, there's a physics to them in terms of their interactions, different shapes. So you might get a growth factor. You might have, actually, some of the cells might have, parts of their developmental program that unfold. But we know from like mammals, for example, that the developmental program is largely signaling molecules between the cells, or, in C. elegans, it's mainly the genetic program in the cells itself, although, the environmental context is important. So now that they start to take on a shape like this, you start to get more cells than just what you have in the ball. You start to get these defined shapes. And this isn't really, this elongation is pretty common in development in other, you get this axial formation. This sort of stuff is more like just something I made up as an example. But then you also have, so then you have things like you want to grow like an ear or some other type of thing that you want to transplant into, because this is why they're doing it. They're doing it for regenerative medicine. Sometimes they're doing it to study, in neural organoids, they're doing it to study, they want to build an analog to a brain. So you have like a, this is like a brain here. I don't know if this is a really good picture, but anyways, this is like, it's an analog to a brain, and you get these cells differentiate and become neurons, and they get wired up, and then they're outputting, like there's electrophysiology going on in these structures, and they're forming these sort of so eventually you want to get to something called 6-layer cortex, which of course, as we know, is like this part of this is supposed to be a human brain or a primate brain, so there's a big cortex, and you have 6-layered cortex, so you have like, I think that's 6. Anyways, that the cells are arranged in these layers like this, and you have connectivity going downwards and over. So these cells are connected at each layer, and there's also connectivity going downwards into the other layers. And so that's really kind of what we want to get to ultimately with organoids, are these 6-layered structures of cortex, these sheets that might be, of different shapes, and this layering. And so this is actually something we're talking about a little bit in the MetaBrains project, and also if you know anything about the Numenta artificial intelligence, they use cortical layers a lot. So this is the kind of thing we want to maybe replicate eventually in organoids. But you're really just trying to grow structures that are complex. And in our case, we're looking at neural structures. So, these cells would be connected together, and there'd be signaling between them. So if people aren't aware, these cells will start to divide and differentiate, but they'll still sometimes retain gap junction contacts. And so those contacts are important for signaling between cells. It's called electrical connectivity, but then that's still not like the kind of connectivity we think about in terms of like a neural network, which is synaptic connectivity or chemical connectivity. And that's where they reach out an axon from one cell and synapse on another cell's processes and establish what they call a chemical connection, where you can get chemical communication between the two cells. And so you get both of these kinds of connections and development that form. And we want to see, what that looks like in a context where we can control the media, we can control the environment, and maybe even the geometry. So we can end up with something like this. Although I don't know how much they've accomplished 6-layered cortex, but it's definitely like we want to make this, and the point of doing neural organoids is we want to make this as realistic as possible. So we want to be able to have like structures that look like biological structures, controlled growth, and then see how those processes work. And so for our purposes, we're interested largely in the data collection and analyzing the data so we can maybe say things about development. In DivaWorm, I think we've done a number of papers where we've analyzed cell tracking in embryos. So this is where you have an embryo, and the embryo, we have markers in each cell that tell us where the cell is in space and how it's moving. And we also have data on connectomes, so we know that cells are connected to one another. And so we can use those things to infer a lot of extract a lot of principles out of that. So that's something that's, I think, broadly applicable to a number of areas. I don't think people have really ramped up on the quantitative side of things yet in organoids, although I think there are people who are interested in modeling who are starting to sort of pick research questions. So it's still a broad open field. But then there are also a number of measures that people are using, like the challenges to get like measurements that are what they call non-terminal, so they have to be like something where you don't kill the specimen while you're measuring it. So it's a problem, and that's something we talked about yesterday. But also something that we can get like that's informative to say something about what's going on in that process.
Very interesting.
Yeah.
Just took a sneak peek at genetic stuff as well, and we'll talk about that later. But I'm excited about that. I've been looking for like there's a periodicity paper which I'm going over, but I've been looking for like what to focus on in DivaWorm. This looks like an exciting mesh of a lot of things for me. And I'm really curious. Like I look forward to talking to Logan about this, because I think a lot of people who are like adjacent or directly in the space, and I feel like I am adjacent to understanding all of their stuff. So it's like, all right, now like the excuse of asking all these questions that have been on my mind for a while. So
yeah,
that'll be good. Yeah.
Does it and like if you're thinking of like one of the hot areas for the last decade or two has been like computational biology. So like the problem there though with education is people will come with like a very strong background in computational methods or data science or whatever. And then like the biology is like this brick wall. You have to learn a lot about the biology to get anywhere. I mean, they can give you data sets, which is typically happens like in bioinformatics. You get a data set and you analyze it. But the problem with that is like, what am I even doing? I don't know what, like I'm just measuring variables. It could be like, analyzing traffic at a grocery store or like, something going on in the cell. Like there's no difference in my mind. I'm just analyzing data. And so that's a problem because you're not really sensitive to what, the actual biological processes. And so that's something that I've been working on for a while, like trying to figure out how to overcome that. My preference is to really kind of infuse a lot of, systems biology into that, like basically getting people like interested in the system and then say, okay, here's some numbers you can put on it. And then, move on to the other stuff that they came for, which I think is effective because it helps you think about like more broadly about what you're doing,
I feel like I wish I could like phone a friend and like literally insert Logan in this conversation because he's a biology guy and he would like, I know he'd have a bunch of research about, okay, well here's what you should look at first, and I feel like, I will be going on that journey myself. Like I have very limited experience in biology, and I've spent some time in a neuroscience lab, but I think I want to be like someone on that journey for sure. So. And I think, like, and also like personally speaking, like I think it's. I've said for a while, like I'm interested in the concept of embodiment in a very broad sense, and like this is embodiment in like the flesh in the most real sense, and it's sort of like I feel like I don't think as in a very Gary Marcus sort of way. No, I don't think we have to be bound entirely by biology in terms of looking at what cognition can do, but particularly like the neuroorganoid stuff, that's like there's some innovation in that in a biological sense, and that's a very really curious way to approach it. And it also reminded like of the bioinformatics stuff reminded me of Stefan, and I hope he's doing well. So it's good to meet him, and I know he's like deep into that stuff and doing a lot of things about that. He's masters and beyond. So shout out to Stefan for his great work.
Oh yeah, definitely.
Inspirational lab work in the past. So it's cool.
Yeah. And I think actually if you get involved in this MIT program, we talked before about getting some data science, practical data science stuff up and running in the lab here. I think that would help because, this could be kind of like the test case where we get like a system up and running for people to come in and do projects and just kind of do, the steps of data science, like almost like a practicum. Like how do you go from like a data set, just, on just a raw data set to processing the data, getting things analyzed, having like a sense of like, developing a sense for what methods to use and all that. Because, I know like when I trained in, bioinformatics, it's like that's basically what you would do. You'd have like a data set and you'd analyze it. You'd do some heavy lifting, but then you'd also eventually figure out like what methods to use, get an intuition for like, this is a good method. This violates, maybe this violates the assumptions of the data. Maybe it doesn't. We want to be able to evaluate those things as we go along. So you don't like go down a blind alley and like, end up with a result that's not supported by the test that you're doing. Like we've talked about Bayesian models. Bayesian models have a bunch of assumptions built into them. Typical statistical models usually do. Machine learning models, of course. So,
speaking of like, this reminded me of. I think I posted this in Slack, but shout out to upcoming Neuromatch Academy 2021. That is happening. There was a form. I think I linked the form in our Slack, but Megan Peters, I think she paired it on Twitter somewhere, but they're starting to put feelers out for people who want to be involved with that. And there's going to be a follow-up deep learning component with the course that Coding's working on. That I'm kind of helping volunteer, like in the most. I'm not the most involved in it, but I've done like a minor reviewing some of the content. Because I'm not there yet, but there'll be NeuroMatch Academy and a NeuroMatch deep learning component coming up again this summer. So just if you're looking at this and thinking, oh, I'd like to get involved with that stuff, you're gonna have some opportunities in the lab, and I'm sure Bradley and I and probably some other people here in the lab will be involved in NeuroMatch Academy again because honestly, that's like one of the things. Like totally honestly, I feel like out of all the things that I'm pretty sure are going to happen this year that I look forward to and that I know I'm going to have a good time at, NeuroMatch Academy is like really high compared to everything else that could happen and like what's going on in stability or whatever. Like NeuroMatch Academy is like something you can invest some hope in and feel like it'd be a safe thing to do. So that's part of why I'm hyping it as well. But that'll be fun. And January's already gone, so it's like that's something.
Oh yeah.
Good or bad, I don't know, but it's something.
Yeah, it was pretty good last year, and hopefully this year it'll be a little bit more refined. Like they'll figure out what went wrong and what went right.
I'm looking forward to it so much, and I feel like I kind of, I had some constructive criticism at times about it, and I think also just being a second time approacher to it will be better too. So
Yeah.
I look forward to. It's gonna be great. It's gonna be great.
Yeah. So let's see. Next, why don't we move into the like the GitHub and project boards next?
You want me to go over the board or something?
Yeah, if you want to do that.
All right. Yeah. When should I talk about the ethics in society, whatever card or project to?
Oh, if you want to talk about that first, yeah, we can do that.
I'll try to do it like this. I think this will work. Alright. Just share this whole screen. Alright. I think I'm sharing my screen now.
Yeah, I can see it.
Just quickly to go over this, I'll double dip a bit here. I put this together. This is pretty much set. It's not quite ideal, but you get the idea of some stuff. And I'll make it a medium post eventually about it, but I would really like, I'm keeping it open because I don't, yes, there's kind of a theory, philosophy component, which is important, I think. And yes, I did make I made a repo. I didn't make a team yet, but this is all in a repo here on Ethics and Society. So it's there, and I'm working on the. Here's a flyer for the event. This is when it's going to be, but like the submissions are due the 5th of December. So I'm really going to be submitting something to that. Also, Min Tran, who I've met from Envision, and I think my good friend, and knows Anson, she reached out to me a little bit, and we'll probably be collaborating on all this somehow, and probably focus on probably related to like the Google AI ethics board stuff, because it's been a really hot topic and it's come up multiple times and was really big at neuro IPS, and there still is ongoing. If you're following any of that news, like just the way that Timnet is still engaging, and different people are coming up and talking about stuff that's been happening, and so there's going to be stuff happening there, and there's been some progress on this front, and also the AI Now project, which I mentioned before. I don't think I have anything about that here, but there'll be some submissions to that as well. So stay tuned for that. And as far as the project boards, I'm not really there yet, but I'll get there. So here we are. I made a few updates here. We'll go back. We'll do our sort of order for stuff. Old business. I kind of want to keep this up just because this is Anson's project, and I don't know if I should close that out yet or not. The project cars, they're not quite done yet. I still want to make one for, I think we did the coding, we have coding futures to finish out forever for me. There'll be one other one. Oh, developmental AI, and I might just update that now. We do. What's left right now? There is a 1, 2, 3. Dev AI. Neural Organoids.
Yeah. And
I think that's
talk futures.
Let's see.
Allostasis machines as well.
Oh yeah. Allostasis machines here. Okay. All right. Great. Okay, that'll be at least a little bit more active actually at this point. So this is pretty much done now. Really, this is I don't know. I need a better name than Ethics Society or like Tech Society. I don't know what to say, but that's ongoing. I have reached out to Princeton, but I think I need to reach out a little bit more about Princeton admission stuff. I put that at the top of the list because I didn't do that. Gibsonian information paper. We're still working on that.
Yeah.
Is that just you, or who else is working on that right now?
I'm working on it. Danielle was working on it, and you were working on it.
Okay, I gotta add. I did get Danielle's GitHub, and I'll be.
Yeah. Actually, yeah, I can invite her to the GitHub because I have her.
Yeah, it's I think it's like Athena-AI or something. I don't know if you have her, but I'll send that to her. I'll sort that out a little later.
All right.
Cellular programming. Is this?
That's been submitted, but
good.
yeah, we have to wait on the reviews for that. So that's pretty much done.
Is this your paper? This is your paper, right?
Yeah, that's mine.
Okay. Well, good job. I don't know what to say to this, but...
It doesn't really fit into any category. Probably that one, yeah.
All right. Nurture Lagrangian structure. Is this is the Evolvable Frontiers one? Is it?
Yeah. So
okay.
that's. I'll go ahead and submit that the way it is now, and then we'll see what they say about it. I made some changes to the. Well, we did some editing of the text, and then I made some updates to the figures, just basically making them higher resolution. And but yeah, it's ready to go, at least in submission form.
Okay. Okay. Whoops. Allostasis machines. How's that one?
That's the one that I submitted it as you can submit it and then update your submission until the deadline. So I put a version in. They extended the deadline to the 14th. So if you still want to make changes to it, you're welcome to do it, and I can update it, and then update the submission. But that's been there's a submission number. We're number 1.
Oh, I saw that. Yeah.
So that's more or less done. Although I think if someone we'll be getting reviews back on it though.
I do have some updates for that because I've kind of been. I know that's not really been here, but that's obviously one of his big things. So I feel like I have to. I think I'm just gonna. I said this last weekend, and I apologize for not really enacting it as much. But ideally, today I'm going to finish all the manuscript updates. Okay. My life stability has been very minimal lately, but I want to do that. So yeah. Let's see. Okay, and then Twitter conference. Any updates on that? I guess.
Don't have any more information on it right now. So.
Okay, that's fine. This is. Did I leave a link here? Link isn't here, but this is what I've been mentioning quite a bit. Let me see if I can just quickly find it. I'm not going to go for it. This is the thing that I've been mentioning with the AI Now lexicon. We'll be submitting this as part of an ethics thing. It's kind of a rolling deadline for the next month or so it's not urgent, but I'll mention that quickly. Of a very similar vein, we have the New York Celebration of Women in Computing. I kind of hyped that a little bit already. This is going to show again. here's the. I guess I realize that this background makes probably zero sense to anybody except for those who have been there. But this is like, I kind of want to get pictures.
It's the venue that they have.
It's the venue, and like we all have these really great pictures, which I don't know where they are on the website. It's like everybody took a picture in this chair, and it was great. And you don't see the pictures anywhere, so it's a little oh well. Nevertheless, it's a great event. Everybody should check it out. Cool sponsors. This is my former university, former college, and university here. Really good stuff. I think they have some things on Facebook, and we can plug that too. Not so great. I'm not logging into Facebook here, so it's fine. It actually looks. This site looks a little bit better on mobile, to be honest. Here, this is kind of what it gets down to. Just to kind of highlight this, the fifth. It's a really wonderful thing. If you're a first-time researcher, or you're kind of you're not used to talking, or you're not sure what to present on, it's a wonderful environment. And please reach out to me. I have experience there. I've even been on like the review committee for some of the proposals and stuff, and highly encourage it if you're at all involved in it. You don't have to be a woman. You can be whatever you want to be and apply to this conference. And it's very good and a very supportive community. It actually is one of the best graduate panels that I had ever in my life was here. It will be virtual this year. You don't have to be in New York State. There's 500 word abstracts right now. And they might extend them down the line a little bit, but just get your 500 word abstract out there. You can ask, message to Caroline. You can also message to volunteer, and use this email. I have reached out to them. I look to be volunteering to some capacity again because I love this event. Everybody should support it and do as much as you can. And that's it. There's what was I going to say? Well, I guess I'll be doing it on GatherTown, which has been very popular at many other conferences. So great. So that's my update about that. Yeah. That's active. Follow up on risk. Did we talk about this last time? I don't know if we did. We might have, but I'm just going to mention this again. I had a really cool, I think we talked about this before. Really interesting conversation here. He's really cool, a really cool guy. Worked with Roman Yampolsky about AI risk stuff. And this was just a really cool thread. I think Tony Chamero liked some of these things as well. So this is our friend, I guess I'll say generously on my part. Dr. and John here. And I have these here. These are open, and I was looking at these things. So there will be risk-related stuff in the future, and that's kind of like why when I wrote this description. Actually, I would really like to have the theoretical components or like philosophy and these like thought papers, which are very good. But I do want to have. I would really like to get to a place where I could model some of this stuff someday. So modeling, I don't quite know how to do it yet, but I want to look at it in terms of hopefully some of these things, like being able to maybe create some agent-based models of resilience or shared risk. And I talked about this in the last meeting a little bit, about agents being able to share burdens or capacity and how it relates to risk. And there's a whole lot of really cool stuff here. So I'm going to mention that again. I'll put that, I guess, in the active category now. But that's actually, I'll put that on hold standby.
Okay.
But yeah, that's it. I don't think, is there anything new to put in a new card that we should add and just to put here? I don't know.
Well,
maybe follow up on the organoid stuff or something.
Yeah, let's put one on like sort of organoid, like I guess we could call it an organoid interest group, or organoids interest group, and then organizing that. So like I don't know what it's going to involve yet, but definitely there's going to be like probably a bibliography, and then following up on different things about like data access. And maybe things that we can do, topics we can focus in on. As it's a wide open area, but it's still kind of broad in terms of accomplishing something. It's going to be kind of, you have to find a niche, I guess, is the sort of goal. Because I've tried a number of starts with this, and it's not been easy to do. But yeah, we're at like step 0 on this, so. But
okay. And yeah, like I feel like that will be something. Like I'm not the most hip to like what's happening in the rest of Devo Worm or Open Worm right now, so I know it'll be kind of a mix of who's interested in it and are people gonna take off and go with it. But I'll just say I'm interested in as a means to do a lot of things that I mentioned that I'm going to try to do this year. So I guess we'll see where it goes.
Yeah. So I had a question about issue, which one? The Frontiers in Artificial Life. That was Anson's. So yeah. What was the outcome of that? Like did he write a paper?
I believe that has become a term paper.
Okay.
And maybe at the very least we could get it to be like even if he did like a 5-minute overview of this paper when he has time, and maybe it's like it might even be like a pre-recorded thing. I would love to just have that happen. Like I don't know. Like I think Anthony has something like I'm gonna take care of this morning, which is why I wasn't here. But I think he's doing a little bit better lately overall, so that's good.
Oh, good.
But yeah, what else did you have in mind about it?
Oh, well, yeah, I mean, I think that, I think it was a term paper. We should try to, do something with it. I think some sort of pre-recorded presentation on it would be good. Also, the A-Life 2021 deadline is coming up soon. So I don't know if that's something he could turn into a paper for that or a extended abstract, but...
Mm-hmm.
I don't know how much work would involve, yeah. But I mean, if you already have it there, so I think the deadline is March 7, and it'll probably be extended about a week. So that's
A-Life.
Okay. Yeah. And it seems like something that you could get into one of the tracks, at least as an extended abstract, which would be like a 4-page write-up. But if he's already done the work, it's pretty easy to shape it,
Yeah. Okay. I'll have to follow up with him on that. Any other new cards to put on our task board? This is kind of a project, but I'll put it there too. But
yeah. Well, I don't think we need to make one, but how about for the deadlines, keeping up on deadlines? Or, well, no, maybe not, because we already have the board. Why don't we make 2 cards? One is for A-Life 2021. So that's March 7th. Well, it says March 7th. But that'll be I think a target. we'll probably recycle the paper that we did for the baby minds for that, and then maybe Anson can submit his work as well. So, what else? I think there's also let me see if there's another deadline I wanted to make us aware of.
March 1st. I see a lot.
That's evolution. Yeah, we might have put well, I don't know if anyone in this group is doing an evolution abstract.
Oh, also, I did happen to notice that for those of you, like, there's ICML, which is February 5th also. But I don't know if everything.
Oh, yeah. Oh, ICML, I think that's passed.
Oh, I thought it was
It's January 28th. Yeah, it's, I don't think we had anything.
Oh, mandatory abstract deadline was then, and I guess it's a different deadline then.
Yeah.
Okay. Alright, I saw that earlier today.
Do we have Neuromatch Academy on there? Or, well, we don't know when those are happening, but it's...
I think they did release a date. Let me see if it's... let me quickly... I think you can see this, Neuromatch. I think they did give us a date somewhere, maybe? The date is July.
Okay.
For Neuromatch. Yes. So that's cool. But I don't know when.
Well, we can put that on the deadlines.
Here?
Yeah, on 31.
Oh my goodness. Oh, we already have it.
Yeah,
here.
we do it up at 15. I just thought...
Oh,
it's right next to, I said summer. It says summer, but we could update it to the new deadline, which is...
Um,
I have to go back and look. Okay, July 5th.
Yeah.
Good. Okay. Yeah, that's... And then, there's Neuromatch 4, which we don't know the date for yet, but that's... That like last year we prepped for it, and we might do that again this year, but we definitely want to...
Yeah, I think Neuromatch 4, and like the Neuromatch is done because it's so open, it's like, this is the great... It's like, I kind of feel like, and I don't mean this in like a disparaging way or anything, but like, I feel like everybody should really be trying to submit to that, and like put your project in some presentation form, and go do it. Like I don't want to make it sound like mandatory, but I feel like it really should be. And I've had various iterations of failing at that, and having like hiccups or not being able to do it. Like I think it's a great thing to do, and it should be like get that experience of doing it. So I look forward to doing that, and who knows? Like I'm excited between like the developmental AI stuff, which is this whole huge. That's like a whole treasure chest that I haven't even touched hardly at all with like the bibliography, the different things that we talked about in Slack. And I would love to be able to talk about that there. And frankly, I might even try to find a way to talk about that in person or something.
Yeah.
So we'll see.
Actually, there are two other deadlines I wanted to hit on that board. Just go back to the previous tab.
Oh, this one?
Yeah. So the CSV conf. Well, okay.
Ooh.
We want to make a card for that, but there's a deadline for which one is it? I saw one where there's no deadline. New York Women's Celebration of Women in Computing 28. If you get on to line 28, yeah, put that deadline in. It says TBA right now.
Oh, that's for me. It's 29. Let's see.
Okay. There we go. All right. So then, yeah, then you want to make a card for CSV Conf
Yeah, let's do that.
deadline. And that's 28th of February, I believe. Alright. So that's in there. Okay. So that looks good. Okay. So I think a lot of the I'll need to update some of these as well. I think there's some that like that have already been hit. So but yeah, I think we're in good shape for this.
Okay. Well, I have like this just desire to like pause time and give me like 4 or 5 hours and just hand off manuscripts and just do like so.
It always gets pretty overwhelming, you know, like. But that's one of the skills you learn is like how do you get things. You know, just have to keep up with things, and it'll pay off later. I think when you have a lot. Well, you'll have a lot of deadlines now, but like, you know, it's always a good skill to develop is how to deal with multiple deadlines coming up, and you know, even in the face of like things that are going on, like in the world, but
yeah. Okay. Anything else for the board?
I think that's it.
All right. I think that's probably.
Yeah, I think the other stuff is like calls for involvement, all that. Yeah, I think those are all. Yeah.
I'll make this an issue later.
Yeah.
For the time being, with this. Okay. Whoops. Okay. Adjust this here. What else was next for today?
Okay, so let's see. I'll get into maybe some of the papers that we had. Look at that. Submissions are done. Yeah, we'll look at a couple of things. So the first thing I have here is the Allostasis machines paper as it stands right now. So this has been put into a template for SIGCHI, and so it's in a template, and so now if we update this, I can update both of them at the same time. Thank you, Daniela, for putting this into the template, getting it organized, and then that's where we're going to submit it from. But we'll probably also put out a preprint of this, but we have to wait until the reviews are over, so like probably March is when the preprint would come out. So so the title, this is a bit wordy, but I think it's probably okay. I might change it a little bit, but I don't think it's that big of a deal. The abstract has been rewritten a bit. Again, Daniela helped out with that. So I think let's see how many words it is. I think it can be a maximum of 150 or something like that. So if I get to this count, it's 170. I can't remember if it's like 100, if there's a limit of 150 or not, but I think it's within the range. And then the introduction, homeostasis is internal regulation, allostasis is dynamic homeostasis. So I added a few references to this section. I think it reads a little bit better now, as compared to the last time we looked at it. So this is a nice sort of historical overview of this too. So like this establishes the idea of allostasis machines. It kind of gets into some of the things about homeostasis and some of the historical details about the homeostat and how homeostasis was conceived of originally. I learned a lot about it just by going back through the references. It's really kind of an interesting history. But then then what we're going to talk about next is this idea of allostasis being maybe a little bit better way to characterize homeostatic regulation. So, this is like allostatic drive from Peter Stirling. And then there's like an area of allostasis that is kind of coming up from the free energy principle and other associated topics. So for sort of biomedical oriented people, or there's this one school, which is Peter Stirling and Iyer, they've proposed allostasis as this series of allostatic drives. So it's like homeostasis, but that gives you like one state. But of course, we know that the body and the brain, behavior, they all have multiple states. And so how do you address that? How do you address like state transitions using a sort of a model of homeostasis? So they proposed allostatic drive. So that's one approach. And then there's another school that says, allostasis is a predictive form of inference. So this isn't really unusual, or this isn't really in opposition to the first view, but it's sort of this idea that there's this predictive processing going on. And so that kind of solves the problem of how you can say that something is goal-seeking or something drives from state to state, something has this sort of thermostatic property to it. Although we know thermostats don't have a mind, there is sort of this aspect of magic to it, and this kind of, I think, overcomes some of that. So then to get into the allostasis machines, so this is an image of an allostasis machine. It's basically a state trajectory diagram where you go from an initial condition to a regulated state, and you get these perturbations from the environment, and then the system recovers to a certain extent, or doesn't, and then it just kind of shifts it to a new state. So over time, there's shifting between states. We don't get too much into this distinction between stable state and unstable state, but this is the basic model. And then this kind of goes back to the Bernard's idea of internal milieu, which is this idea of like the body is very complex. The way we can describe it is an internal milieu that's regulated. We don't have to get into the mechanisms, but yeah, you do, because if you want to know anything about like how the body is sort of regulating itself, or any sort of mechanism, you really do need to make those distinctions. So I don't talk about this in terms of reductionism, but I thought about it, didn't know. But anyways, so then we also have innate mechanisms. So like, why is it that this function regulates the way it does? Why is it that sometimes it goes back to normal, sometimes it doesn't, sometimes it goes to new states? And some of the underpinnings of this function, at least from this side, which aren't shown, are these innate mechanisms. And so they're, computational representations of the genome or gene expression networks allow us to model that. That gets kind of glossed over in here, but, I don't know, we have a little bit more room to work on it if you think that maybe we need a little bit more detail there. It's a little hand-wavy, but it's not really, we're not actually implementing it, so it's not critical. But then we get into open-ended dynamical summaries of internal states. We get into open-ended evolution a little bit, and then this dynamical trajectory of the AM. And then this is a figure of where you have an example of hysteresis. So you have this function that is, you have a baseline, you have a perturbation with its magnitude, and then a recovery from that perturbation, and then the recovered state. And so that's all laid out in different points. The recovered state can either be like going back to the original state, the baseline, or it can be like hysteretic, which means it doesn't recover. So it's like if you take a rubber band and stretch it, it either snaps back to its original shape or it's deformed, and that's your hysteresis. And so and this kind of talks about some of the relationships between like sensation and perturbation, and then they kind of define it in terms of what we call neuro HCI systems. So this is relevant to the conference, to the workshop, but it's actually kind of an interesting term because I just kind of coined it here. But there are a lot of like we have brain-machine interfaces, and we have other types of interfaces with neural systems, with biological systems, and HCI. And so I think that's an interesting frontier. We haven't really talked too much about it in this group, but it's definitely, I think, something that maybe, fits into the developmental AI camp in terms of like, if you were to use developmental AI as a way to look at like human-computer interaction, or like, something to do with users. And so that's something that, could be followed up on. Yeah.
I think, and then going into like, I don't know if you're going to say anything specifically about the virtual environments next, but I'm very interested in, I would really like to do something towards the HCI and VR component of this. Like, I don't know if we can fit that in as a place to go in the future, but like for specific like application arenas to do this that affect some like real world stuff that's happening now, I'm very interested in that.
Yeah. I don't know, maybe you want to add in something in this section, because I only got into like one paragraph here of the VR stuff, so it kind of like was in the outline, it was like two subsections, and it ended up being a paragraph. But I don't know if there's a lot to, I don't know what to add, because it's like there's probably stuff in the literature, but it's like one of these things where it's actually probably could add some more into the I'll think about it. VR section. Because I'm thinking like there's some really specific things about like perturbations. So like in the area of therapy, where people use VR for therapy for like motor control, there's a lot of stuff on like where you're like introducing these sort of differential forces. So like people might be on a treadmill and they're watching the scene and they're kind of walking on the treadmill down a virtual path, and then you move the treadmill up in terms of angle, so they start to have to go harder and harder, like they're going up a hill almost. And like stuff like that isn't really usually it's a perturbation, and you can actually measure the magnitude of it. So that's something that maybe I'll put that note in here.
Yeah, this reminds me of two things. Interesting. That's funny.
What?
I was looking at please finish your comment.
Alright, yeah, let me get it done. Alright, I'll know what that is. Okay, go ahead.
Maybe I should wait, because I was going to share my screen.
Oh, no, I can. Let me unshare mine. And then.
Really quickly, there were two things. They're both Twitter related. One of them's part of this reminds me of just yesterday looking at John Crocker's lab, the BLAM lab.
Yeah.
Brain learning, animation, movement lab. And it reminds me of some things we're talking about here, like recovery from brain injury. So this I looked at this yesterday, and my expression was because they changed, or at least it looked different from before. Like they just updated some of this stuff. So that was that. But this might be interesting to look at in terms of what we're talking about. or as an example of it. And since we're doing it right now, I will take a moment to share a particular, let's say, image that came up today.
Okay.
Today's mood, and I tagged us in this, and this cut this from the paper. It adds critical qualitative detail as an advanced argument. It took us months to dig this up, and I want to share it. You have a word limit. So that's
yeah, that's paper writing.
That's today's mood.
Yeah. I think this.
Oh.
Yeah. Well, thanks.
It's very important stuff that I just shared there.
Yeah. Well, that's the essence of paper writing collaboratively. So, yeah. So the page limit on this is not like we're kind of at the low end, like the way they said it. They said 4 to 6 pages, tend towards the lower end if you don't have a lot of figures. So we're kind of like at the beginning of the 5th page. So we could add something in here and probably be all right because we have. Do
you think we'll try to put any more figures together than what we have?
Probably. Well, I get. What were you thinking?
I don't have anything specifically yet, but I could try because I don't know. I don't want to just insert them or anything.
Well, I mean, what's going to happen is we submit it and then we get the reviews back, and then if they want, maybe they want another figure, maybe we can add it in. I think that's the idea, that you can, like, maybe we want to add another figure in. We could fit it in. We have the space. So, I mean, if we want to think about like another figure we could add before, if it gets accepted, even if it doesn't, we can add it to like a preprint version where we have like I don't know what the logical next or third figure would be here. Yeah. So, I mean, if you want to think about that, that would be good. We might want a summary figure, but I don't know what that would look like really.
I'll hopefully look at that.
Yeah.
Yeah.
Yeah. Because I mean, like, it's you gotta get you gotta figure out what it's gonna look like. It's always a challenge to get like one of these. Like sometimes they're purely descriptive, like this one, but like sometimes if it's like a overarching concept, it's harder to get a image.
Yeah.
But yeah. So let me discuss a couple things here. Actually, we don't talk about AI too much in here at all. But they're like, I think limiting it to this is just sort of about like representational capacity, and then like some stuff about embodiment, which we have. But there's like some theoretical work on an action, and that's sort of the focus. One of the foci of the. We need to write a summary, and I forgot about this. A summary of how it fits into the workshop. Almost forgot about that.
Is that separate to the paper itself? It's like a...
No, I think they want it in the paper, but I didn't put it in the submission. I can just update it later.
Yeah, make a comment about that, I guess, and I'll think about that too.
Yeah. All right, and then if you go to the emergentinteraction.github.io is the workshop page. So they have like they have kind of a list of topics, and that's actually like, basically if we're addressing a topic, that's where it fits in. I don't know. So, and then so that's the Allostasis machines paper. Then the Gibsonian information paper is the abstract. This is kind of getting into just kind of outlining Gibsonian information as an alternative to Shannon information. And then this is Gibsonian information inspired by the work of J.J. Gibson provides us with a measurement, with the measurement of information, or with a measurement for, I guess, for maybe. I'm playing around with the, and again, Danielle has helped out with some of the, like thinking through some of the flow of this. So thank you. Then this is something Jesse is going to pick up on here, random and or static background, which is part of the sort of a general, like we have the three principles, the three potentials for measurement, and I guess there's this like a summary of that we can, I don't think that's the best description, but yeah, you said you were going to follow up on that. So you need a stronger contrast with Shannon information here. Now I don't know what that is really. So GI is a measurable phenomenon. Here are the three principles that lead to measurement. Oh, that's off the page now. Okay. So that's disjoint distribution, contingent interaction, coherent movement. All right. And then we get into four-channel embodiment, which is the example. That's an area where we need to fill in this part here, which is, we'll probably reference one of the previous papers, the Baby Minds paper, and then maybe a little bit about development, and then also temporal contingency. And that'll be, put together this weekend sometime. And then we have this figure, which is figure 2, which is the four-channel example, and then discussion, which is just kind of going back over how it differs from Shannon information, and talking about direct perception. And in here kind of gets into a little bit of like representation and direct perception. So there's some, maybe we could charitably call them historical citations here. One of these is Hilario, who's actually someone who, if you're interested in the work of Ron's son, that's another person to check out. So,
could you actually go back to his name and put a comment for me that would just say, like, to put a comment that says Ron's son or something?
Yeah.
Then the RPI guy.
Alright.
You can literally say Ron's son if you want.
Yeah.
Oh.
Similar work to Ron's son, I guess, because they've published together, I think, and yeah, it's a lot of stuff on like representation, and she does a lot of stuff on like data mining and bioinformatics. So that's kind of an interesting take on it. I don't think Ron's son is more interested, I think, in, I don't know, like, from what I saw from Google Scholar, it was more about like pure AI, so that's something that you might check into. So then all these papers here, so the citations. So again, we're at this is supposed to be 6 pages, but in the CogSci template, which is going to make this shrink down. It's a two column template, so it's probably going to be, this is probably going to be our page limit for this. We'll just kind of go through, I'll try to fit it in the template. So the deadline for this is the 3rd, so it's Wednesday. So I got to get this done like by maybe Monday night to get it in the template, and then we'll submit it, and then we'll hear back in April. And again, this is something we can't preprint until we get the reviews done on it. But it's I think it's a good write-up. I'm glad that we got this. Like, this is an idea that's been floating around the group here for a while. So I think if you could think about this part here, which is the random and or static background, maybe break that into a couple of sentences. And I think that's about all we'll have room for. And then maybe we'll move this down so we can give space for that. So just move that down to the end here. All right. And then I think that's probably it. Oh, this part here, which is just more about embodiment and some connections to development. There's this thing called temporal contingency, which actually ties back to Shannon information theory, which is something that I found this paper last night, Temporal Contingency by Charles Gallistel et al. And this is a good paper because it kind of gets into this idea of contingency. Now, in developmental contingency, it's sort of like if you have this set of developmental pathways, you're going to restrict yourself over time to a subset of developmental pathways. Temporal contingency is more about sort of acquisition. So it's like if I acquire a piece of information, what comes next? Not everything comes next. You have to have the sequence of events. I think that's how they kind of approach development in a lot of the existing developmental approaches to AI. They say, well, we can look at development as an acquisitional thing. So, it's like if you acquire a piece of information, then the next piece of information is restricted, and then so on and so forth. So it's like if you learn a language and you learn context within that language, it's kind of hard to then take that context and move it to another language. You have to use that same framework. I mean, you can do it, but it's hard. So that's kind of what this is all about. So this needs to be finished. And then I think that's pretty much it. I think we're in pretty good shape for the rest of it. If you find any glaring problems with it, please point them out. But I think they're pretty minimal here at this point. And again, this is something that'll be the hard deadline for this, I think, is Wednesday. So it's probably going to be submitted Monday night. So, and then the other paper, the one for the workshop, that deadline's been extended to the 14th, but that's already been submitted, one version, so we can update it I have to update it with this statement, but we can also update it with other things as well. So,
okay.
Any thoughts about those two things, or?
Not to add on to them, but I hope to finish going through them today.
Okay.
I also reached out to. I posted something in Slack adjacent to all this stuff, and she might be responding. I asked Daniela if she wanted to, thank you for her contributions, and I asked her if she wanted to say anything. I know she can't be here in the meeting today, but if there's anything she wants me to say on her behalf, and she might be replying out of that. But that's an aside comment.
Okay. Well, let me go to this other thing, and then we'll come back to that. So one last thing. This deadline is February 15th, and this is something that... so this is this SURE workshop. This is the 300 to 500 word abstract. I haven't really touched it.
What's SURE again?
It's something in representations. I can't remember it's SUR and then small e workshop. I can't remember what the acronym is. It's about representations, though. It's more philosophy and yeah.
Scientific understandings and representations.
Yes, that's it.
Oh. Yeah.
Yeah. So this is something on the observers and the scientific method, and this has how many words is this abstract right now? 185. So we have quite a bit of space here to kind of go on about some of these points. So some of the stuff is pretty vague, so it needs to be fleshed out. We'll come back to this soon. Why don't we get past these two deadlines and we'll come back to this in a little bit harder detail. I think, I don't know, maybe if we want to read through it and make sure it makes sense, that's good. Otherwise, I know that there are things that need to be fleshed out in this, is what I'm saying. So, yeah.
Let's make a card for that. I don't think there's a card for that.
Yeah, why don't we do that?
Okay.
Yeah.
We'll do that. It's the deadline's. When is it?
It's the 15th of February.
It's basically like sort of an observer-dependent follow-up.
Yeah.
Okay.
Okay.
We got a lot of things cooking right now.
Yeah. I think we get past March and it slows down a bit because everything is in the summer or spring, and it's like everything, all the deadlines are now. So I think that's the problem here. Hopefully. So that's okay. Then we'll go back to that one. Then finally, I wanted to get to. Oh, did you hear back from Danielle at all, or?
Let's see. I think that might be replying right now. She says she can't attend in person, but you can say that she's really happy to collaborate on basically the papers, and looking forward to working with us in the future. And she asked if we could send her a summary of the meeting, so we'll have to write one up and put it on Medium and send it to her, something like that.
Yeah.
But it's just good things right now. No major like comments, but she's happy to work with us all. She's been active in the papers and in Slack and stuff. And that's great, and that's sort of like routine oral and distributed lab and making work. I feel like that's. I've been thinking how much I really appreciate the fact that yes, Saturday mornings are a little bit tough, but I will take it all the time because the flexibility of the lab and being able to I have every intention of kind of moving this year. I was going to move last year, so being able to be distributed is a huge blessing for me. I appreciate it, and even the work with Daniela and Rashad, who again isn't here, but he's still very active in our community. Miz joining. Anson is ever present, even if he's not here. And a lot of other people who we met through, NeuroMatch and other stuff are sort of external collaborators in the GitHub sense, and they're still with us. So it's a cool thing. I appreciate it.
Yeah, that's good. So I'm gonna go to these papers. So this is usually how we finish up the day. So I've got a couple papers that I found. Let's see what we have in the folder. You see my screen?
Yeah.
Okay. So yeah, there was something that you posted in Slack. This emerging technologies and trends impact radars. This is Gartner. This is where they say. So these are where there's a mass, I guess, of a critical mass of the technology, and this is concentric circles going from now out to 1 year, and then out to 6 to 8 years. So this is these are things that are coming to a critical mass now, sort of in the middle, up to a year from now. These are predictions that they make. This is just based on market research. So deep neural networks is about a year out. And then something like transformer-based language models is about, maybe 1 to 3 years out. Let's see, IoT platforms are maybe 3 to 6 years out, and then the AR cloud or some of these other quantum computing is even farther out, which, this is all qualitatively. This isn't they didn't go into the future and come back and report on this. It's just their projections. Something called composite AI, which is interesting just because it's something we've talked about with respect to MetaBrains. But it's more kind of along the lines of combining different AI techniques to get a better result. So like if you were going to combine, say, reinforcement learning and evolutionary computation, you might be able to come up with something that's better than either approach, that gives you an answer faster, overcomes some of the limitations of each approach, as you would see if you just applied those approaches on their own. So then there's stuff like I've never heard of before, digital twin, which I imagine is something where you have like a synchronize yourself and your digital self. So there's a lot of interesting stuff, and I know that this is like one way to look at this graph as like this set of concentric circles, but there's a more sort of traditional way that they look at this, which is the hype cycle. So I guess this is the same information, but it's in like sort of a time series. But they also, if you look at the hype cycle figure, and I think this is for 2020, and as well as this one, the concentric circles one. So this is the same information, but they actually show these phases of time. So like in the other figure, they kind of showed like the time horizon for each of these technologies. In this case, they actually have those time horizons color coded, but notice that they're kind of jumbled up in order because they're actually using a different metric here. What they're using is these different categories. So you have an innovation trigger, which is something that triggers the innovation to happen. Like so maybe it's a flash of brilliance, or maybe it's like combining other things together. And then you have this thing that's invented, and then you have this peak of inflated expectations. So what happens in technology typically is you have like something like, say, adaptive ML or responsible AI. It gets invented, and then there's a lot of hype that surrounds it. Like, oh, this is great. This is going to change the world. Yeah. But of course, it's not really been used very much. So it's just kind of this idea. And then as it's implemented, there's this inevitable sort of trough of disillusionment. So this is where you get like people say, oh, that's all it can do. Or, like with, I think people have been looking for this in deep learning, where they're like, well, deep learning can solve everything. And then you figure out that it can't solve everything. So then people kind of go in the other direction and they say, well, it can't really solve anything. That's sort of the dynamic that's driven the AI winters. There are AI summers and AI winters. The AI summers are sort of like where you get a new innovation and it becomes this peak of inflated expectations. So, and then when at some point that innovation sort of goes through this trough of disillusionment. So, neural networks went through that. Connectionism went through that in the 80s. So you had this innovation. People thought, oh, this is great. And then they said, well, it's not really going to get us to general AI. So you went through this trough of disillusionment. But then you have this slope of enlightenment and plateau of productivity, which is where people realize that, yeah, maybe you can use connectionism for some useful things, which is a slope of enlightenment, which would be like where people were kind of coming up with deep learning techniques. And then this plateau of productivity is where what you see, I think, with deep learning sort of now with, respect to like people, maybe 10 to 15 years ago, didn't really want to talk about, neural networks because they didn't think they were useful. But now, of course, people are like, well, maybe, we've seen some, things that it can do. And now people are releasing platforms that are stable and that are targeted to specific domains. So maybe this is workable after all. So this is actually quite a common feature of technology evolution. And I thought that we should talk about that a little bit, because I know that Jesse's interested in the evolution of technology. So, and also AI summers and AI winters. It'd be interesting to see if we could just look at this in terms of AI summers and AI winters, but that's so that's interesting. Let's see. Well, the three other papers I wanted to go through really quickly here. This first one is a Quanta magazine article. What is an individual? Biology seeks clues in information theory. And so this is about some work that people have been doing on, they're looking sort of to explain sort of how do you recognize life. If we were to go to another planet, could we recognize life if we saw it? But we also don't really understand life very well on this planet. And so we need to find an objective definition of life's basic units. And so this is kind of what people are doing with information theory. They're trying to develop a more general objective definition of life that encompasses things like individual organisms or collectives, social collectives like social insects, or even things like tornadoes or weather systems, which, we wouldn't think of as living, but, they interact with the environment and they're dynamical systems. So we don't, it depends on your definition of life. So more than 500 million years ago, during the Ediacaran period, a surreal world of life overran the ocean floor. Its bizarre soft-bodied animals had physical forms that defy the imagination. Bolted blobs and rib discs, segmented tubes and upturned bells, tapered spindles and slender cones. And so these are the first multicellular organisms. Now, we wouldn't necessarily recognize these if we looked at life today and we thought, well, is this what we would have expected life to look like back then? Or if we went to another planet and saw this, would we expect, would we think of this as like complex life? And so this is kind of what they're getting at. This is why we need, stronger definitions of what life is. So this, I know we talked about this in DevaWorm last week, about the deep history of life. So this is kind of timely in that sense. What does it mean to be living? We have all sorts of model systems, but those model systems are often not there's no average life. So you have bacteria that swap genes. Sometimes, other species can hybridize. Slime molds work collectively so that there's the role of an individual is very suspect. It's the same thing with social insects, but then other species have distinct individuals. So it's really kind of that's a hard area, say, just that area, to make a definition of life. So is life collective? Is it individualistic? Is it, symbiotic? Is it competitive? Well, it's all those things depending on what order or what organism you're talking about. But they kind of get into this, search for definitions. They cite Maxwell Ramstad and Melanie Mitchell, we've talked about in the group here. So Maxwell says, the notion of what it means to be an individual often gets glossed over. So far we have a concept of individual that's very much like the concept of pile. If there's a pile of sand, you intuitively know that it's a pile of sand. But a pile is not a precisely defined thing. It's not like after 13 grains it moves from a collection to a pile. So they also point out that biology is under-theorized. So that's one of the problems. We don't have good theories of life and of biology in general. We have some, like natural selection, but others are very kind of hard to get our hands around. So here's David Krakauer, who's from Santa Fe Institute. So he's leading some of this work. Jessica Flack is also at Santa Fe. This is Scott Gilbert, who's a developmental biologist. And one of the problems is that we have switched from a biology of classification to a biology of genes. So it's hard, we've always had this sort of bias towards different levels of organization. Biology started out as sort of classifying natural kinds, and then we quickly moved into sort of this view of the gene, a gene-centric view, which is, what we need really is a biology of processes, which kind of brings these things together. And then we talk about individuality. So there's some papers that, if you're interested in, there's a Theory of Biosciences paper that includes this formalism, which I don't think I included in this folder, but you can go find that reference if people are interested. And it's a really interesting topic. I don't know if I should say much more now, but if you're interested, you should read this article. It's a Quantum Magazine article here. So you can read more about it on your own. The second paper is Reconciling Emergences, an information theoretic approach to identify causal emergence in multivariate data. So this is about sort of quantifying the concept of emergence. So it kind of relates to the last paper. So the concept of emergence has been very broad and maybe qualitative and intuitive more than it's been quantitative. So we see things like, swarms of social insects, and we say that's emergence. But then we see other things and we say, well, it's not emergence. But we don't really have a good, rigorous definition of it. So this is the issue here. And they're coming up with a quantitative definition of emergence in this paper. So this article introduces a formal theory of causal emergence in multivariate systems, which studies a relationship between the dynamics of parts of a system and macroscopic features of interest. So like in social insects, you have your individual insects, and you have like a nest or a swarm or a set of ant trails. And those things are different at a different level of organization. And so our theory provides a quantitative description of downward causation and introduces a complementary modality of emergent behavior, which we refer to as causal decoupling. Moreover, the theory allows practical criterion that can be efficiently calculated in large systems, making our framework applicable in a range of scenarios of practical interest. We illustrate our finding in a number of case studies, including Conway's Game of Life, the Reynolds flocking model, and neural activities measured by ECG, basically, electrocorticography. So they've actually not only come up with the theory, but they're implementing it in different ways. And so the main contribution to this work is to enable a rigorous quantitative definition of downward causation and introduce a novel notion of causal decoupling. Another contribution is to extend the domain of applicability of causal emergence analysis to include cases of observational data, in which case causality ought to be understood in the Granger sense as a predictive ability. Furthermore, our framework yields practical criterion that can be effectively applied to large systems, bypassing prohibitive estimation issues that severely restrict previous approaches. And so they get into this difference, or these sort of causal decoupling and downward causation issues. They have a diagram here, some math, formal theory of causal emergence, and then partial information decomposition. So we get into some of the technical details, defining causal emergence. And again, you can read the paper if you're interested. There they apply some integrated information theory. So they're looking at integrated information decomposition. So this is where they're looking at a network of nodes, and they're looking at how downward causation and causal decoupling work in this model. And then let's get down to the model systems at the case studies. Okay, so like I said, there's Conway's Game of Life. So Conway's Game of Life gives these particles on a grid, and they're coherent. So that results in coherent self-sustaining structures that allow for information transfer and modification. They do a simulation of the Game of Life. So they have some results here. The Reynolds flocking model, which is otherwise known as the Boyd's model. This is where we have these different birds that we're simulating flocking by looking at their interactions collectively. And so you kind of get into this model. They have some results. And then they have this Mind from Matter, which is looking at neural dynamics, and they have some results there. So again, if you want to look at this paper, it's really, really detailed, really good paper. The last paper I will talk about in a couple minutes here is Deep Learning Systems as Complex Networks. So this is from the Journal of Complex Networks from 2019. And this one is actually interesting if you're interested in data science and networks and deep learning. So deep learning, of course, is a network, but complex networks are a different type of network. If you've seen hairball networks, where you have a bunch of nodes and a bunch of connections like a hairball, I think you know what I mean. That's a complex network, and it's very different from a deep learning network. So deep learning networks are one thing, complex networks are another thing, and one class of deep learning models known as deep belief networks can discover intricate statistical signatures in large data sets in a completely unsupervised fashion by learning a generative model of the data using Hebbian-like learning mechanisms. These are self-organizing systems. In this article, we propose to study DBNs using techniques commonly employed in the study of complex networks. So they use complex networks techniques to study deep learning models, especially this type of deep learning model, in order to gain some insight into the structural and functional properties of the computational graph resulting from the learning process. So you have these networks that learn, and then you want to analyze the network when it's learned something, and you use these measurements from complex systems networks, complex networks, to understand that. And so they get into deep learning networks, they get into some recurrent neural network architectures, sort of motivate the study. Then they get into deep belief networks, which are a little bit different. They're set up, they're built as a stack of restricted Boltzmann machines, which I'm not going to get into what that is, but you can look that up. And then they get into some of the network architecture details, network-based analyses. So, network analyses are basically analyzing graphs. And so you're using things like looking at the connectivity, you're looking at, k-part type graphs with random weights drawn from a Gaussian distribution. So you're looking at like random networks versus the topology that's generated in the learning networks. These are the kinds of things you do in complex network analysis. And you can look at things like neuronal receptive fields and clustering of receptive fields and the distribution of weights. So you can look at that as a function of where things happen in the network. You can identify things like modularity and other types of clustering. Again, you can go through it if you want to learn more. Definitely, if you're interested in deep learning, this is an interesting approach. I was thinking maybe I should do a talk on complex networks sometime in the near future, because I think that's going to be useful to a lot of things. And that might actually be something I might cover, is how, the relationship between that and deep learning. So, I think that's a good place to stop. I just went over those papers really quickly, and I'll put the link in the chat here. So that people, only Jesse's going to be able to link on it directly, but that's something that you can look at later. And I think that's it for today. Did you have anything else to add, Jesse?
No. Papers are good. I got manuscripts to do. A lot of exciting stuff, and there's deadlines and there's stuff to flesh out. We didn't talk anything today about developmental AI stuff, but there's there's a a lot of stuff to do, and it's just going to be pushing forward with that. So hopefully, I want to make some progress on the stuff that's immediately due, and I'd like to continue to have some specific focus on the developmental AI stuff. I don't really know how to quite do that yet, but I want to administratively put that out there. I don't want to lose that, and we won't. But I'm just, it's in my mind. So that's it. That's all. But I think it was a good meeting. I don't have anything more to say, but thanks for all the people who aren't here that are still collaborating. I'll give that a shout out again. But that's all for me.
Yeah, and we'll follow up on the developmental AI stuff in Slack. We've talked about, I think in the last week, about making a preprint with sort of the details of it, but that's coming up in the future. So we'll talk about that maybe next week.